Let's solve salaries differences on StrataScratch. They ask us to write a query that calculates the difference between the highest salaries found in the marketing and engineering departments, and then to output the difference in those salaries. Let's figure out what that even means. They give us two tables, and the first is called Database Employee. That table has 5 columns: ID, first name, last name, salary, and department ID. If we click preview here, we can see what that table looks like, right? We have our 5 columns and just rows of employees. For example, Keith Morgan, he makes $27,000 and he has a department ID of 2. We could just see every employee at this company in this table. The second table, Database Department, has only 2 columns, ID and department. If we preview it here, we can see the department ID is a number, and we have the department name, which refers to the name of the department. So a department ID of 1 refers to engineering, 2 means human resources, and there's 6 departments total at this company. Now that we know what the data looks like, here's just a little example table of the first one with some rows from, this is not all of them obviously, but this is a few rows from the first table and a few rows from the second table. Now that we know what the data looks like, let's reread the question. Calculate the difference between the highest salaries found in the marketing and engineering departments. Before we can do that, we have to figure out who is in marketing and engineering. This first table alone doesn't tell us, right? We have Aaron Fisher, who makes $45,000 about, and he has a department ID of 1. Well, what does that department ID of 1 even mean? We have to go to the second table to see that, hey, department ID of 1 refers to engineering. So if we were to combine this table, right? Say, hey, department ID of 1 means engineering. We can figure out that Aaron Fisher is in engineering. Likewise, for Christopher Ramos, who has a department ID of 4, hey, let's check the department table. What does 4 mean? 4 refers to marketing. So Christopher Ramos must be in marketing. Pamela Rodriguez also must be in marketing because she has a department ID of 4. Brian Nelson will be in engineering, and Randall Kramer will be in human resources. We have to combine both tables together to get all the information we need, because there's no way we could have known which employees in what department with this first table alone, because a department ID alone doesn't tell us we don't know if 1 refers to engineering or marketing or whatever. We have to take the second table and combine it with the first one to see, oh, department ID of 1 is engineering, so Aaron Fisher is in engineering, and we can then figure out, find everyone in engineering and marketing for our question. Whenever we combine tables like this in SQL, it is called a join. We are joining 2 tables together. And the query would look something like this. It would take the first table, for example, let's just select everything from the first table. Then we say join the name of the second table that we're joining on, database department. Then we specify how we're joining them together. We are joining them wherever department ID is equal to the ID in this table, right? We want to find wherever there's a match between these 2 columns, between these tables. So we can say department ID is equal to ID. Normally we'd have to specify the table name of the column, but in essence it would look something like, if we were to join and write a query to join these 2 tables, it would be the first table, join the second table on the 2 columns that we're joining on. Like this is going to tell us how do we join these 2 tables together, right? We need a column to join them together on. What would this look like once we joined it? I have a table here. This is what the joined table would look like if we ran that query. We have all of our information from the first table, right? All of our employees along with their salaries and department IDs. And then because we joined the second table, the department table, wherever these 2 were equal, we were able to append the department, all the information from the second table. We only joined wherever these 2 were equal, right? We have a row here of all information, and then we said, hey, check the second table. Wherever ID is 1, take that whole row. And we joined it together. And now because we did, we can see Aaron Fisher is in engineering. We have all of our information in one row that we would need. Christopher Ramos is in marketing, and we have a salary, we have all of his information. Now that we've joined these 2 tables together, we have everything we need in one place to begin this question. Let's go back to StrataScratch and let's run this query, exactly what we wrote, and see what it would look like. So select star, select everything from the first table, database employee, join the name of the second table, which is database department, the department table, specify how we're joining them. We are joining them on this column from this table, so we have to specify the table. Because hypothetically, what if there was a column in this table also called department ID? We would have to specify the table so there's no confusion. Database employee dot the name of the column from the first table equal the second table and the name of the column in the second table, which is ID. Let's run this, and what do we get? It's exactly what we had in our example. We have all of our information from the first table, and we appended all of our information from the department table, wherever these two were equal to each other. Department ID equal to ID. And this makes this question solvable, because now, how do we know who's in engineering? Well, let's just do where department equals engineering. Simple as that. We can now filter based on what we need. And look at the output. We just got everyone in engineering from our company. We can do the same for marketing. We also need people from marketing, so let's check what that would be. Run the code. Hey, there's everyone from marketing. The first step of this question is done, and the rest just becomes trivial. What we have to find is the highest salary in marketing and engineering. So let's do it for marketing first, because we already have marketing here. How do we find the highest salary? Instead of selecting everything, let's just select salary. We have a list of all the salaries in marketing, and to find the maximum, we can use the max aggregate function, which will aggregate everything, all of our rows of data into one result based on what the function is. And here we see we have 48,187. This is the maximum salary in marketing. What about engineering? What would the maximum salary in engineering be? Just change this here. Oh, sorry. Run code. 45,787. That's the maximum salary in engineering. So we just found both the highest salaries. If only we could do this, right? Just copy and paste it and say, hey, find the highest salary in engineering minus the highest salary in marketing. And do this. Just subtract them. That would give us the difference, right? In SQL, we have to cover the whole thing in a select statement. So let's do this. Select. Indent this. Cover this in one. Right? We would get our first result, the maximum salary in engineering. Get our second result, the maximum salary in marketing. Run our code. And we get negative 2,400. So we got a negative value because the highest marketing salary is greater than engineering, and we want to return the absolute difference as per question. So we want to return a positive value always. What we can do is cover the whole thing in an absolute function. So this whole bracket, this whole thing, and put absolute and run it, and we get 2,400. If we check the solution, that is the correct solution. So this question can be broken down into three parts, where first we figure out we need to join the two tables. And once we join them, we have all of our information in one place. After that, we filter on the departments we need, where department equals engineering, where department equals marketing, then get the maximum salary from each, and then just find the difference. Thank you very much.